Hello to the tech community out there, and welcome to another episode of Tech with Kraado. My name is Chris. Today, we'll learn to encrypt AWS IAM user password and AWS secret key in Terraform State file. It is important to note that when using Terraform, credentials such as IAM user password as well as IAM secret key are always stored in plaintext, despite the state file itself being encrypted. This represents a serious security risk, as any ill-intended person that gets hold of those credentials can easily compromise your infrastructure. Let's jump to our first lab to create a user and then examine the state file. First, let's clone our repo. Get clone. Now let's take a quick look at the code. In the main, we have the provider definition. This block creates the user. Then we have the console password block. Here we have the access key and a secret key session. This refers to the privilege where we actually call upon some IAM policy and then pass it on to the user, and these are the variables for the IAM policy that will be assigned to that user. And here we created the user with a username called Kraado Encrypt, Kraado Unencrypt. And then here we have the output. Now let's go to the terminal, navigate to our directory, and run terraform init. This will initialize the module. Now we run terraform plan. Let's take a quick look at the plan. I guess all looks good. Now let's just run terraform apply. Say yes. Okay, this has created 7 resources. We can now go to the AWS console to quickly take a look at that to confirm that indeed the user has been created. Now let's jump to the Terraform State file to see if indeed the credential of that user is stored in plain text. This is the credential session. This is the password in plain text, and then this is the secret key. You can also go further down and confirm that this is the secret key, as you can see over here. And then we have the password that is also right here in plain text. In order to prove that this is indeed the password, let's just try to log in as this user. Let's go to the AWS console. And then we also going to pick up the password that we've seen somewhere here, or we can even go up here and just pick it up. And we are in by simply copying a password from the state file or a credential from the state file. We've been able to have access to this AWS account. Now let's see how we can use encryption to mitigate this risk. Luckily, Terraform supports a PGP arguments that allow you to encrypt those credentials using a public key. What is PGP? It is simply a self-managed public key program where a data is encrypted with a public key and can only be decrypted with a private key. And Terraform allows you to encrypt credentials with PGP using Keybase, which is a free public key cryptographic platform owned by Zoom. Keybase generated key are RSA 4096-bit. To use Keybase with Terraform, first, the user must have a Keybase account. At the time of the creation of the IAM user, Terraform will retrieve the user public key from the Keybase platform and encrypt the password or the credential before storing in the state file. Let's jump to our second demo to set up our Keybase account. We start by asking the user to create a Keybase account by going to keybase.io. Click on Login, join Keybase, provide an email, a username, and a password, and click Activate. And they'll get a notification for them to activate their account. The next step is for the user to generate their PGP key by clicking on Add PGP key. Need a public key. This will generate a 4096-bit key. Provide a username and then an email address, and then provide the account password. The key generation is completed. You now have both a public and a private key, and this is the public key. Keybase also allows you to retain or to host your private key on your portal by keeping this option checked, which allows you to use the portal to decrypt messages. After the key generation, the user can simply install the client application of Keybase by clicking on this link and select their preferred client platform. Keybase also allows you to keep your private key completely offline by using the Keybase client to generate the PGP key. Let's look at an example. We're going to use the account of a second user called Kraado 2, which currently doesn't have any PGP key. We now log into the PGP client using his username and his password. Now we register his device, user 2, that's just a name for his computer. The user is logging. Now let's go to the command line. First of all, let's confirm that the user is logging by using Keybase my command. Now let's generate our PGP key using Keybase PGP gen command. Provide your PGP account email. Would you like to upload your private key to the Keybase portal? Here we say no. Say yes to encrypt your primary key. Now it's generating the key. Now provide your Keybase login password. Now use Keybase PGP list to confirm the existence of your primary key in your local key store. Back on the portal, we can confirm that the user 2 public key has been uploaded, as this is required by third party to encrypt messages, but the private key is not. Let's jump to our third demo to create an IAM user with PGP encrypted credential using Terraform and Keybase. Now let's clone our second repository, which has the encrypted user configuration. Git clone. Okay, let's go to the code. The encrypted session, or the folder, here it is, same configuration, with the exception that this time we're going to provide some few new value. Here we can see how we have Keybase argument added to this for the user, for the console password, as well as the secret key session. Here it is. Now let's define the user to use. We're using this Kraado user 1. Here we're going to change the sensitivity to 0 just to be able to output the value for you to see. Okay, let's run Terraform init once again. Terraform plan. Okay, you can see it's going to create the same number of resources, 7, using this argument, the password session. Here now we have the PGP key. Oh, thank you. I'm just going to fix this one. Kraado user 1. Now we can go back again and run Terraform plan. Terraform apply, just using a new flag today. Auto approve. This is the output. We now have the credential. This is the access key. The console password now is an encrypted format, as well as the secret key. Let's quickly jump into the Terraform state file. And this time, if we go into the state file, exactly the same thing. The console output password is this one, and then the secret is here, all encrypted. Now let's attempt to decrypt this particular credential. And to do that, we just go back to the console, copy the ciphertext, go to Keybase console, Go to decrypt and paste in the encrypted password. Before we can decrypt this, we need to add a PGP header and a footer. Remember to maintain the blank line between the header and the body. Finally, you put in your password and click decrypt. We can now copy the decrypted password and test our login. Provide the AWS account ID, the username, and the password that we decrypted. And voila, we've logged in successfully. Now we can reset the password. Another way of decrypting your credential is to use the Keybase client. In case you've generated your PGP using the client and store your primary key locally. In this example, we'll be using a new user called Kraado user 2 that I've created behind the scene using the Kraado user 2 PGP key. First of all, let's confirm that we are logging as a Kraado user 2 using Keybase who am I. Let's retrieve the encrypted credential of this user using Terraform output. Let's decrypt this by copying this whole block with a double quote and pipe into Keybase PGP decrypt command using echo. This X when we hit enter. Here we are. This is the password for this particular user in plaintext. We can try the same thing with the access key, the secret key rather. And this is the decrypted secret key. This brings us to the end of this episode. In addition, we'd love to hear from you on how you manage and preserve credentials in Terraform in the comments, as well as any question that you have. If you find this video helpful, give us a thumb and don't forget to press the subscribe button as well. Thank you for watching and see you in our next video.